Namaskara students, welcome to V Karnataka KCET and boards. I am Diksha Kaushal, your chemistry master teacher, and today, yes, it is the second part of electrochemistry, not the first part, right? We have already done first part of electrochemistry. I will ask the team to change the title as well as the thumbnail. Okay, don't worry about that. Yes, students, so today is a very important topic, right? That is Nernst equation. Right, not yesterday, in the previous lecture, we did some of the basic things about electrochemistry, like what is E naught, what is electrode potential, what is Daniell cell, how to calculate E naught cathode and anode, right? So, is there any problem in the previous lecture? If so, then write it down in the chat box so that we can start with our today's lecture. Everybody, yes, Mandar, yes, Anoop, Mahadev, Khush, Abhishek, Shri Vishnu. Okay, guys, so shall we start? Shall we start? Everybody in this chat box. Shall we start? And yes. Okay. Ready, everybody? If yes, then green hearts in the chat box. This week classes were less. Okay, we will have more classes for you then. If you are ready to deep dive into the classes and if you're ready to have that much load, then definitely. But yes, classes are as per your requirement only, as per the requirement of KCET exam only, right? Okay, if you are ready, then green hearts in the chat box because I love greenery, right? Okay, yes, everybody. Now, let me have the fresh slide, right? Wait a minute. Okay. I think that is better. Now, let us see what exactly we did yesterday. So, yesterday we did one thing which is very important. We talked about the reducing nature. We talked about the electrode potential basically, right? We talked about electrode potential. In electrode potential, right, we talked about E naught of cell equals to E naught of cathode or anode. E naught of cathode, right, E naught of cathode minus E naught of anode. Now tell me one thing, is there any specification regarding whether it should be reduction potential or oxidation potential? I told you that there is one specification here, that the E naught that you're going to take here is reduction potential, not oxidation potential. If you're going to take oxidation potential here, the formula will variate here. That is why fix it in your head that you are going to use reduction potential here, right? That is why here we will write reduction potential, and here also that is reduction potential. So that becomes your formula for electrode potential, that is E naught of the cell, right? Is that clear to everybody? Yes. Okay. Okay, sure, Mandar. Definitely, I'll on my Telegram channel, that is Diksha Kaushal Chemistry official. In that channel, I will every week I'll give you a proper timetable regarding my chemistry classes for NEET, for JEE, and as well as for KCET, right? So that you guys can plan accordingly, right? So this is E naught cell is equals to E naught cathode reduction potential, E naught anode reduction potential, right? But ma'am, if they ask about this E naught, this is in the standard conditions, isn't it? This is the standard conditions. These are the standard conditions, right? Standard, it has no variation with pressure, no variation with pressure, or you can say concentration and pressure. That means here the concentration and pressure should be, concentration should be unity, right, in the standard condition, right, and your pressure should be 1 bar. That is your E naught of cell. Now, if they are talking about a general thing that they have not specified any concentration or pressure here, then what will you do, right? Then we will have this thing. If they have not specified anything, if they have not specified a proper unity concentration, they have not specified 1 baric pressure, then in that case, it is not called as E naught cell. it is called as simple E cell, right? It will be called as simple E cell, right? Now the question is how to calculate this E cell, right? To calculate this E cell, we need to check what is Nernst equation and why Nernst equation is so important, so that it's just not about cramming the formula of Nernst equation, also to understand how to apply that formula, that is also important for you. So, right, so in today's lecture, we are also going to take up some numericals based on that. Right, so here to calculate this E naught cell, we have this equation called Nernst equation that I'm going to write here, right? That is N-E-R-N-S-T, Nernst equation, and it is the most predictable topic for your KCET, most important topic for your KCET, right? You can, I can guarantee you definitely a question will be based on Nernst equation or E naught cell will be asked to you, right? This is that important to you, right? So here, what basically is Nernst equation? Let us see that firstly. I'm going to write the equation here. Here you calculate the E cell in form of E naught cell. E naught cell minus RT minus RNT. R is gas, universal gas constant that has a fixed value. Temperature, right? It can be fixed or it can also variate. If nothing is given to you, that means the temperature is constant. They have taken the room temperature here, right? So RT divided by NF. What is N here? N is the number of electrons gained and lost. Or you can say this is called valency factor or N factor, right? N factor, I will tell you in detail. In detail, I will tell you how to calculate N also, right? How to write this thing also. E naught cell minus RT NF ln of QC, right? Ln natural log of QC. Now, write it here. What is QC? QC is reaction quotient. This you must have studied in 11th class PU1, right? That is called reaction quotient. In which chapter you have studied it? Anybody in the chat box? In which chapter you have studied it? You have studied this in which chapter? This you have studied this in equilibrium chapter, right? Kc, that is equilibrium constant, right? When a reaction is not under equilibrium, then we say QC, right? Then we calculate QC for it, that is products, concentration of products divided by concentration of reactants raised to the power the stoichiometry coefficient, that is called QC. But at equilibrium, that QC will become Kc, right? That is called QC reaction quotient, right? So this is your reaction quotient, right? So now I am going to write down here what is R? What is R? R is gas constant, universal gas constant, right? Then we have a T, that is temperature in Kelvin. What is N? N is N factor, that is number of electrons gained or lost in a chemical reaction, right? Then we have N, then we have F, that is Faraday, that is 96500 coulombs, right? Okay, so this becomes your overall thing. Now, there is a way out of this, that you don't need to put the value of R, T and F again and again. So they have simplified this and they have already calculated the value of this whole thing, or I would write one more way you can write this. Instead of writing ln of QC, you can write one more thing here. And what is that? You can write, this will be multiplied by 2.303, because we are going to convert it into log base 10, right? Log and anti-log we did, right? So here we are going to convert it into log base 10. That is why I am multiplying this by 2.303, right? Rest of the things will remain same. This is RT divided by NF. This is log base 10 of QC, or we can just directly write log of QC, right? Because other bases are not in your syllabus, you can just directly write log base 10 or just directly write log, right? Log of QC, right? So now let us simplify this equation and understand that how to apply this equation, right? Okay guys, yes everybody, very good, 0.0591, very good. So now they have calculated this value already, right? This value will turn out to be E cell equals to E naught cell minus 0.059 divided by N log of QC. This becomes the formula that you are going to apply everywhere, right? This is your basic Nernst equation formula, right? This is how you're going to solve the numericals, right? Now, ma'am, the next question is, how will we calculate E naught cell? How will we calculate N? How to know what is the value of QC? Right? That is the main task here. Right? So we will focus on each thing, like one by one we will focus on each thing, right? So first is E naught cell. How to calculate E naught cell? Everybody in the chat box, this I told you yesterday itself. E naught cell will be calculated as E naught of cathode, right? Reduction potential. I am going to write it again and again so that you can never forget this thing. E naught of anode, and this is also reduction potential, right? E naught is sorted. This will be given to you. This will be given to you in the question itself, right? This E naught cathode is given to you. This E naught anode is given to you in the question itself, right? Now, next thing is how to calculate the value of N, how to calculate the value of QC, right? How to calculate the value of N, how to calculate the value of QC. This I will tell you in the question, right? Okay. So this, let us see one example here. Let us see one example. For example, they have given you A 2 positive 2A plus B2 positive, right? This is the question that they have given you, right? A 2 positive to A, B2 positive, right? These are the equations this is the equation that is given to you in the question, right? Now, let us see how to calculate the value of QC firstly, right? How to calculate reaction quotient here. Now, if I don't know if you remember equilibrium or not. So, assuming that you don't remember equilibrium at all, right? That's why I'm, in detail, I'm telling you how to in every reaction, right? How to calculate the value of QC, right? So, students, we know one thing, that the solid, right? So, basically, what is QC? QC is concentration of products divided by concentration of reactants raised to the power the stoichiometry coefficient, right? So I'm taking the stoichiometry coefficient. Let's say this is let's say it is A and this is A. Let's say this is B and this is B, right? So I'm assuming this is AA, this is BB, right? Now QC is product by reactant. So firstly, what are the products? Product is A, product is B2 positive, product is, and what is reactant? Reactant is A2 positive and reactant is B. These are the products by reactants, right? Now, I am saying raised to the power stoichiometry coefficient. So here it is stoichiometry is A, here stoichiometry B2 positive, stoichiometry is B, here stoichiometry is again A, and here stoichiometry is again B, right? QC is what? Concentration of products divided by concentration of reactant raised to the power the stoichiometry coefficients, right? Now there is one thing, if you remember that, if you remember equilibrium, we write one thing, that the concentration of pure liquid or solid is unity. We take it as unity. So here, this is your pure solid, right? Because this has not been reacted yet. This is in solid state, this is in aqueous state, this is in solid state, this is in aqueous state, right? That is the reason we will not, this term, this A concentration and this B concentration will turn out to be unity, because the concentration of pure solids and pure liquids, this is aqueous, that is turning out to be, pure solid and liquid, that is turning out to be one. So here it is not a pure liquid, it is in the aqueous solution, the ionic solutions, right? The ions are involved here in the water. So this is not a pure liquid. This is a pure solid, right? So for pure solid, it will be 1. So here it will be 1, here it will be 1, and this is what you will have. That is why what we are going to write, the concentration of products, only the ions we are going to write here, raised to the power the stoichiometry divided by, this is A2 positive raised to the power the stoichiometry, right? This is a one way to understand this. Products divided by reactants. Now, students, tell me, is there any issue in that? Is there any problem in that? To understand that, how to calculate QC? Now, I'm going to give you a very, very simple thing, right? See, This can also be written in the form of oxidation and reduction. How to write it, right? In some question, it will make it really, really easy for you to answer the question quickly, right? Because numerical will definitely take time. So we want to practice it so much that we can answer it just in 1 minute, right? So now let us see this B2 positive. Now tell me, from B2 positive and from A2 positive to A, where you see the reduction, where you see the oxidation, right? If you talk about B22 positive, right? So here, can I say this is 0, this is plus 2. So that means the oxidation number is increasing, right? So if your oxidation number, let us write it here, if your oxidation number is increasing, and here if you see, it is plus 2 to 0, right? Here, as you can see, the oxidation number is decreasing, right? So here you can write it here, oxidation number is decreasing, right? Oxidation number is decreasing, here it is increasing. So when your oxidation number is increasing, right? So when your oxidation number is increasing, that is called oxidation. So can I write here oxidation? And can I write here reduction? Can I write here reduction? Right? So always, like always, what you will see in these kind of questions, QC will be equals to the ion which is taking part in the oxidation divided by the ions which are taking part in the reduction state, raised to the power the stoichiometry coefficient, right? Okay, so one way is this one. I know right now, so you will feel like, ma'am, this is a longer way, ma'am, this is more easy way. But in the question, when you're solving the numericals, right? So in that way, because to calculate the value of this n, eventually you will have to separate these two equations into oxidation and reduction to calculate the value of n factor. That is why I am saying that this is also another method, right? So if we ever get confused in that, what you will do? Oxidation by reduction, right? Okay, understood? Simple, right? Now, we know that how to calculate E0 cell. We know that how to calculate QC. Shall we proceed with how to calculate n factor? Right? So here the n factor is very simple. Can anybody tell me in the chat box what is n factor here? Can anybody? Kirti, Sri Vishnu, Mahadev, Abhishek, Mandar. Yes, students, Sneha. Can anybody tell me what is the n factor here? Can you see here that here it has been increased by what number? It has been increased by which number? Wait a minute. It has been increased by 2, right? That means 2 electrons are getting lost, right? 2 electrons are getting lost. And here 2 electrons are getting gained. 2 electrons are getting gained, right? Definitely it is reductions. 2 electrons getting gained, 2 electrons getting lost. That means the number of electrons that are gained or lost is equals to 2. So can I say that n factor here is 2? N factor here is 2. Can I say that? Yes, students, everybody, very good, very good, very good. So this becomes your full equation, right? Now I'll give you one more example, right? More are the examples to calculate the value of n factor. I'm giving you one more example, right? Then we will do some numericals based on this, right? So one more example is, if you have, let us say you have A3 positive, right? This is A and this is B, this is B2 positive, right? So here you need to tell me what is the n factor, right? Here you need to tell me what is the n factor. QC, we will do that in the question itself. Firstly, let us talk about the n factor. Let us see if you are able to predict that or not, right? So that's what I told you. Nernst equation, remembering the equation is not difficult, right? I would say not even calculating, doing the numericals is also not difficult. But this is where students get stuck, right? That is why in detail I am telling you how to calculate the value of n for different cases, right? Apart from this, you will not see any other case, right? So these are the maximum cases that they can tell you, right? So here, as you can see, let us divide this, right? This is aqueous, this is solid, this is a solid, this is aqueous, right? So now let us see that. Here it is from A3 positive to A, and this is B2 positive, right? can I say one thing here? A3 positive to A, right? That means plus 3 to 0. That means oxidation number is decreasing, right? Can I say this is reduction? This is happening at cathode side. And here it is from 0 to plus 2. Oxidation number is increasing, 0, then 1, then 2. That means oxidation number is increasing. So can I write here, this is oxidation, this is oxidation. Right, students? This is very good, very good, very good, very good, Suni. So here, this is called oxidation. Right, everybody? This is oxidation. Now, reduction and this is oxidation. Let us see the next thing here. Now, very simple. Here, if you can see that, here it is called the reduction part. How many electrons it is gaining? Definitely, it is gaining 3 electrons. Right? That is why it is getting converted to A. It is losing 2 electrons, right? Here it is gaining 3 electrons, here it is losing 2 electrons. But number of electrons lost and gained should be same. That is why we will multiply this whole equation by 2. We will multiply this whole equation by 3. Right? So 3 into 2, 6. 2 into 3, 6. Right? So what it will become? What it will become? It will become 2 into A3 positive. Ma'am, it is so simple, ma'am. We are ma'am, very smart, ma'am. We know that. This is 6, right? So this is very simple, no? So what we did, we have to make the electrons same. The number of electrons gained and lost should be same. It is possible only if I multiply this by 2, it will become 6. If I multiply this by 2, it will become 6. So number of electrons gained and lost should be same, right? So then it will become, this is 3B, this is 3B2 positive. Now tell me, till here, is this clear to all of you that why I multiplied this by 2, why I multiplied this by 3? Yes, students? Is that clear to multiply by 3 and 2? Yes? Yes, Mandar, is that clear? Students? Everybody? So here, why I multiplied this by 2, why I multiplied this by 3? The reason is the number of electrons lost and the number of electrons gained should be same. That is only possible if I multiply this by some stoichiometric coefficient, right? Now, the equation, the overall equation is going to change, right? This is where students do mistakes, right? So here the overall equation will not be this. The equation overall will be, because here it is gaining 2 electrons, it is gaining 3 electrons, so it will become 6. Because we have multiplied this by 2, we have multiplied this by this one, so it will become 6 here, right? So when we add these two equations, 6 will cancel out each other, and in the end it will become, 2A3 positive plus 3B give rise to 2A plus 3B2 positive, right? So this will become the overall equation. This is an aqueous state, this is an aqueous state, right? So now even the QC is going to change, right? If you see this equation, you will directly write, ma'am, oh ma'am, QC is very easy, ma'am. We can just write QC, ma'am, we can just write QC equals to B2 positive, ma'am, A3 positive, ma'am. This is so simple, ma'am, right? But what will happen? In the exam, you will do this mistake, right? And this is wrong, right? Why? Because after balancing the number of electron, the N factor is turning out to be 6. And the overall equation is also changing. So the QC will become equals to product, that is B2 positive raised to power 3 divided by reactants, that is A3 positive raised to the power 2, right? So this will become your QC, and what is N? N will be equals to 6. Now students, tell me, is that clear to everybody or not? Is that thing clear to everybody, right? Okay. Is that thing clear to everybody? You can go through this again. Okay, take time, go through this again. Is there any step that you're finding difficult? Any step? Yes. If no, then yes, definitely. Josh in the chat box, your energy in the chat box, show your energy in the chat box, right? So that even I can know that, yes, ma'am, everything is clear or not. Crystal clear? Perfect. Very good, very good, very good, Mahadev, Shri Vishnu, Mandar, very good. Now, what about others? What about others? Very good, Sumi. Okay, perfect, perfect. Now, we have done QC and we have done this. Now, let us see one numerical. Are you all ready for one numerical? Everybody in the chat box, ready for one numerical? Okay, let us do one numerical based on this, everybody. Yes, everybody. Okay, now your ma'am is writing one numerical on the board and take out your notebooks, take out your pen and try to solve this along with me, right? Okay, try to solve this along with me. Now I'm giving you this question the question is Zn2 positive. Now these are so many things, right? So your 0.01 molar. This is cell representation is given to you, right? Cu2 positive to Cu. Here the concentration is given to be 0.02 molar, right? This is given to be 0.02 molar, right? Now they are asking you to calculate the value of E cell if, they have also given one more thing here, that if E naught of Zn 2 positive to Zn and E naught of Cu to Cu2 positive, it is given to be minus 0.34, right? Then it is given to be minus 0.76. Now you need to tell me, now if you are able to understand this question, no one can beat you in Nernst equation. I can guarantee that you will definitely be able to do Nernst equation question in the exam. That is my promise to you, right? Okay, everybody, each step I will tell you, every single step we are going to see that in detail, right? So first thing is everybody, so first thing is we need to see how to calculate the value of E naught cell, because that is there in the Nernst equation. So firstly, let us find the value of E naught cell. Okay, so what is E naught cell? Everyone in the chat box, E naught cell is E naught cathode reduction potential by E naught anode. But ma'am, we don't know what is cathode, what is anode, ma'am. So let us do one thing. Firstly, let us see that which one is cathode, which one is anode. So I told you one thing. That AC. Do you remember this? I told you in the last lecture, right? AC. What is AC? AC is anode and cathode, right? This is your anode side, this is your cathode side, right? So AC, right? Oxidation, anode, or you can just remember this thing, LOAN. L means lost or lose. It loses electron, and then this is on the left side, this side. O means oxidation, A means anode, and N means a negative electrode. Just remember lone, okay? So now that means oxidation is going to be on the left side, right? Oxidation is what? Anode side, right? So that means on the left side you will have anode. So this is your anode side, right? And this is your cathode side. And this is your cathode side. Okay, so that means we are going to write E naught cell as E naught of cathode. What is cathode? Cathode means we are talking about copper, right? So we have to write E naught of copper minus E naught of zinc. Now we need to write the reduction potentials. Let us see whether they have given us reduction potential or oxidation potential here, right? So let us see that. Here they have given 2 positive to 2. 2 positive to 2 means definitely it is losing the electron, is it? Let me see. Here 2 positive to 0 it is. Yeah. So plus 2 to 0. So oxidation number is decreasing. That means reduction is happening. That means here they have given you reduction potential only. So this is reduction potential only. That is so fine. But here what they have given us? Reduction potential or oxidation potential? It has nothing to do with this thing. You just need to see that what they have given you, right? In the question, whether in this part, whether the oxidation number is increasing or decreasing. It should be decreasing. Only then we can say they have given you reduction potential. This I have told you yesterday in the previous lecture itself. Here it is 0 to plus 2. That means oxidation number is increasing. So when the oxidation number is increasing, they have given you oxidation potential, not the reduction potential, right? That is the catch here, right? So they have given you oxidation potential. That means if you directly apply this formula, then the answer will be wrong, right? Then the answer is turning out to be, it will turn out to be wrong, right? So here, this should be Cu 2 positive to Cu, because we want to decrease the oxidation number, and minus E naught of Zn 2 positive to Zn, right? So if Cu2 positive, Cu to Cu2 positive is this, then E naught of Cu2 positive to Cu will be negative, because oxidation potential is negative of reduction potential. So it will be 0.76 volt, is it? It will be 0.76 volt. Is that clear, students? It will be 0.76 volt. Now the answer is going to be, this is E naught of cell, this is E naught of Cu, and this is going to be, this is they have given us to be 0.76 minus of, this is minus 0.34, so it is minus 0.34, it will turn out to be 0.76 plus 0.34, which will turn out to be 1.1 volt, right? So this will become your answer for E naught cell, right? This will become your answer for E naught cell, right? In the question, they can also ask you directly what is E naught cell, right? Okay, is that clear to everybody? How we calculated, what was the trick here, what was the difficult part here, right? So here, this was the tricky part, right? This was the tricky part, right? What you need to remember, that take the reduction potential of both of them, right? That will be cathode. Firstly, you need to understand from this representation what is anode, what is cathode, right? That is the first thing. Second thing is, you need to see that whether they have given you reduction potential or they have given you oxidation potential. As you can see, here it was oxidation potential, not reduction potential. Okay? Okay? Ma'am, one more question you are saying? One more question? One more question. I have not completed the question yet, right? It's just this one step I have completed for this question, right? It's just I have calculated this E naught cell here, right? This is the first step, right? I'll give you one more question to calculate the E naught value, right? Tell me, is this thing clear to you or not, right? Okay? Yes. Now, next thing is to calculate the value of which thing? To calculate the value of QC and N factor. For QC and N factor, you need to firstly write down the full equation. So here we know that at anode, what is happening? Reduction is happening. At anode, oxidation is happening. So that is why there will be loss of electrons. So Zn to Zn2 positive, definitely oxidation number is increasing, right? At anode, oxidation is happening. Oxidation means oxidation number should increase. At cathode, reduction is happening. That means oxidation number should decrease. Right? This is the best way to understand. At anode, oxidation is happening. Here, oxidation should happen. So, Zn to Zn2 positive, 0 to 2, that means there is, number is increasing. No, from 0 to 2, number is definitely increasing. So, here it is Zn to Zn2 positive, right? First. Second is, we have, here you have Cu2 positive to Cu, right? So from Cu2 positive to Cu, it is from 2 to 0. Oxidation number is decreasing. If oxidation number is decreasing, that means reduction, right? So reduction, you can write it here, Cu2 positive to Cu. These are the things that are happening. Cu2 positive to Cu, Zn, this means this is on the reactant side, this is on the reactant side, this is on the product side, this is on the product side, right? This is on the product side, this is on the product side, right? Now, this is a full-fledged equation, right? Now, if you write it individually, we know that Zn2 positive. So first equation. Second is from Cu2 positive to Cu. Here it is oxidation, that is why it is losing the electron. 2 electron it must be losing. If from 0 you subtract minus 2, then only it will become, if you subtract 2 from here, from 0 you are taking out 2, then only it will become plus 2, no, right? So if you have 0 and you are taking out 2 electrons from there, then it will have deficiency of 2 electrons. That is why it is plus 2 here, right? Here it is gaining 2 electrons, right? So it will be on this side. So it is plus 2 electron give rise to this, and when you add these two things, it will become this equation, final equation. So the number of electron gained and lost are 2 only. That is why n factor will become 2. And what is the value of QC? QC can be defined from this equation, product by reactants, or you can simply, that's what I told you, no. If they have given you, you can also understand oxidation by reduction. You don't need to write this full thing. If you remember just one thing, that is product by reactants, and that is Zn2 positive by Cu2 positive. There is no change in the stoichiometry because there is no multiplication here. Already it was 2 electron, so there is no need of multiplying it with anything, right? So the equation is same only, right? N factor you have already calculated. QC you can calculate by two things, right? One thing is product by reactant. Product is what? Zn2 positive. Reactant is what? Cu2 positive. Or you can even think it like this. Oxidation by reduction. Oxidation is happening on this side, and on this side Zn2 positive is the ion. And on the reduction, I told you oxidation by reduction here. Right? And here the reduction is in case of this case. Right? So here the ion is Cu2 positive. So we have written Cu2 positive. There are two ways of remembering this thing. Right? Everybody in the chat box, tell me if this thing is clear or not. If this thing is clear or not, if you're able to understand that how to calculate the value of E naught cell, how to calculate the value of N factor, how to calculate the value of QC. Right, everybody in the chat box, is that clear or not? Right? Okay, guys. Everybody. Yes. Now, we just need to put the value here. This becomes E cell equals to E naught cell minus 0.059 divided by what is N? N is 2, right? Log, what is Q? Q is Zn2 positive. What is Zn2 positive? That is 0.01. 0.01 divided by 0.02, and this will become half only. So it will be 6. This is what is E naught cell? That is 1.1. So you can just directly write it here, 1.1. So it is 1.1 minus 0.059 divided by 2. Wait a minute. So this will become log of 1 by 2, because these these decimals will cancel out each other, right? So it will become 1 by 2. You can also write it as 2 inverse. So it will be 2/9 divided by 2 log of 2 inverse, you can write it, right? What is -1? You can take it here. This I told you, those students who are not able to understand the log part, I have already taken up a lecture of log and anti-log, right? Okay. So now it will be minus 0.0. You can also say this is 0.06. 0.06 divided by 2. It will become 0.03. Approximation I am using here, right? So the part that is in the power will come in front of it. So it will be -1 in multiplication log of 2, right? Now it will be 1.1 minus will be plus. It is 0.03 because it will cancel out. It will be 0.03. And what is log 2? Log 2 is 0.301, right? Just need to calculate this and see what is the value. It will turn out to be 0.009. So it is 1.1 plus 0.009. So answer will be 1.109 volt. That will become the answer. Okay, everybody. Now tell me, is that clear to you or not? Yes? Very good, very good. 1.105, 1.1, just 0.009 is adding here, right? So earlier also it was 1.1. Again, if you write it 1.1, then the answer will be wrong. See, the difference is very small. Earlier it was E naught was 1.1. So how much amount is getting added here? That is 0.009, which is a very small amount. So you need to mention that, right? Okay, understood? Yes, everybody, is that clear to you or not? Everybody, let me see how many students have liked this session, right? Let me see how many students appreciate the efforts that your teachers are doing for you guys. Okay, guys? Yes, everybody, all the students here. Shall we do one more question based on this? Okay, shall we do just one? Because one student asked about that, ma'am, give me one more example. So I am not giving you like full-fledged numerical here. Just tell me how to calculate the value of E naught here, right? How to calculate the value of E naught here, and what is the value of N here, right? So this is mg. Just need to tell me few things here, right? What is the value of N here? Right, this is 2Ag positive, give rise to Mg2 positive plus Ag. Right, what is the value of N here? What is the value of QC here? 0.001, and this is 0.130. 0.130, right? Okay, guys, everybody. Now, what is the value of N here? As you can see, it is from Mg to Mg2 positive. Is this reduction or oxidation? This is reduction or oxidation. It is going from 0 to 2. That means oxidation number is increasing. That means it is oxidation, right? And here it is reduction. Other one is oxidation, means at anode. Oxidation means at anode. And the other one is Ag positive to Ag. Here it is going from 1 to 0. Oxidation number is decreasing. 1 to 0, it is decreasing. So decreasing means reduction. So here this part is the reduction part, right? So here we can write this is the cathode part, right? Now tell me, is this thing clear to you or not? Now we know one thing, that in anode there is loss of electrons. So it is going from 0 to 2, that means 2 electrons are getting lost. So we will write lost means on the right side you have to write, right? Because it is losing electrons. No, so it will be minus 2 electrons. It will turn out to be here and it will be positive. So this is plus 2 electrons. Then we have here you have plus 1 to 0. That means it is gain of electrons. So gain of electrons will be written like this, right? Gain of electrons will be written like this. There is 1 electron that we will gain, right? Now, number of electrons lost and gained should be same, right? So this will also be multiplied by 2, right? That is why they have directly given the equation like that, right? What if they don't give you equation like this? What if they give you this thing, right? Then also you need to understand that you will do this on your own, right? What if in the question it is given like this? What if in the question it is given like this? There is no stoichiometry coefficient that they have mentioned. Then this is the same thing that you will do, right? Answer will be 2 Ag positive plus 2 electrons give rise to 2 Ag, right? So this is the first equation. This is the second equation. This is the first equation. This is the second equation, right? You just need to cancel out the electrons here, and then the equation, the full-fledged equation will become Mg plus 2Ag positive give rise to 2Ag plus Mg, right? Plus Mg 2 positive, right? This is the full-fledged equation. Now, 3 things I asked you. One is number of electrons, that is 2 electrons are gained and lost. What is QC? QC is oxidation by reduction. What is the oxidation part, or you can say products by reactants? Product part is Mg2 positive. So Mg2 positive, write it here, Mg2 positive, the concentration of Mg2 positive divided by concentration of Ag, that is the reduction part, Ag raised to the power of the stoichiometry coefficient, that is 2, but here there is no stoichiometry coefficient, so that is 1 only, right? So this will become, but how to solve question in 60 second KCET, because only 1 hour for chemistry and there is 60 questions, right? So how to solve? See, not all the question will be numerical based, right? So don't worry about that. You have to some of the questions that are direct conceptual based question, you can solve this in just 5-10 seconds. This is how you need to divide it, right? There will be lengthy questions also like these, right? There will be very direct questions from either your naming reactions, from distinguished test, either from some exception of inorganic chemistry, or maybe some concept directly from your physical chemistry, right? Or maybe some very easy calculative based question, right? So those questions are also from biomolecules, right? That is the theory part, right? They can ask you. Those questions you can do that in 10 seconds, right? If you know the answer. Now, rest of the things, if you say that, ma'am, can I do this question in 1 minute? No, right? Let's be real here, right? Let's be real. You need to take that time. You need to take out that time from the other question, right? So that you can save the time here, right? This is how you solve any competitive exam, right? So easy question will be there, which will take you around 10 to 15 seconds. These lengthy, not difficult, I would say lengthy question, they will take like 2 minutes, right? But if you have good practice, then you can even solve this in maybe, I would say if you don't have practice, then you will solve this question in 5 minutes, right? If you have practice, then you can solve this in maybe 1 to 2 minutes easily, right? But for that, you need to have a good practice here, right, students? Okay. Around maybe 10 questions will be lengthy like this, right? All the other questions will be very, not easy, I would say conceptual based. We can't say that the question that you can solve in 10 seconds is easy, right? Maybe they can ask you just one word question, right? From biomolecules or maybe some organic based reaction, right? That is, if you know, you know, if you don't know, you don't know, right? That is those kind of questions, theory based questions, right? Okay. So around like 50% or maybe 40% question will be like that, right? There will be some question that will take you around 1 minute, but there will be some question that will take you 2 minutes, right? But the lengthy questions will be very less, like very less, right? So this is actually one of the lengthy questions, right? Okay. So this is QC is equal to Mg2 positive, Ag positive squared. This is how you calculate the value of Ag, right? Now, you feel that, ma'am, this is actually lengthy, but if you do this, if you practice this, this question can be answered in 1 minute or even less than that, if you have a good practice, right? So now this is QC. What is E naught? If you can define what is E naught, what will be E naught here? What is E naught? Wait a minute. What is E naught, everybody? What is E naught? E naught is cathode by E naught anode, is it? E naught cathode by E naught anode, right? So E naught cell, you will write it as E naught cell is equals to E naught cathode. What is cathode? Cathode is this one. So it will be E naught of Ag positive to Ag, because we want to decrease the oxidation number. +1 to 0, it is decreasing, right? So this is the reduction potential. You need to see this thing in the question, minus E naught of, should I write Mg to Mg2 positive, or should I write E naught of Mg2 positive to Mg? Everybody in the chat box, tell me, should I write this or that? Everybody in the chat box? Yes, everybody? Yeah. Should I write this or this? Here they have given you 0 to +2. 0 to, number is increasing. So increasing means oxidation. I told you, you need to write the reduction potential, not oxidation. So answer will be E naught of Mg2 positive to Mg. By chance they have given you Mg to Mg2 positive, just change the sign here, opposite sign, add minus to it, right? And you will get your answer, right? Is that clear? Very good. Very good. Is there any problem till now? Any problem till now? Everybody in the chat box. Is there any problem till now? Is there any problem? Okay, now let us write this equation again. Now, two, three more equations that are related to this question, like Nernst equation. Let us write that. E cell is equals to E naught of cell minus 0.059 divided by N log QC, right? Now, at equilibrium, if you talk about at equilibrium, the important thing is, at equilibrium what you have, QC will become equals to KC. As I told you, at equilibrium, QC will become equals to KC, right? So we can write it here. QC is equals to KC. Now, at equilibrium, E naught cell is also equals to 0, right? E naught cell is also equals to 0. Sorry, E cell is also equals to 0, right? E cell is also equals to 0 at equilibrium, right? Now, here the new formula that you will see is 0. Put the value 0 here, it will be 0. This is KC. So answer will be 0 E naught cell minus 0.059 divided by N log of KC. Very, very important equation I am writing here. So you take it on this side, it will be E naught cell equals to 0.059 divided by N log base 10 of QC. Log base 10 of QC. Everybody? This is E naught cell is equals to 0.059 divided by N log base 10 of QC. Is that clear? Yes. Now, this is E naught cell, right? So that is your very important equation. Wait a minute, this is KC, not QC. Yes. Now, what is KC? That is equilibrium constant. Now, if they give you the value of if they give you, for example, they give you E naught cathode, right? E naught of anode they give you. They ask you calculate the value of KC here. You just need to put this value, you just need to apply this value, apply this formula, right? And take the anti-log. That is why in the log and anti-log lecture, I told you that you also need to understand how to calculate anti-log. Reason was this thing, right? Reason was this thing. We will do numericals based on that in the practice sessions, right? But this is the formula, right? That is E naught cell is equals to 0.059 divided by N log of KC, right? For example, if you talk about, if they ask you calculate the value of KC here only, right? If they ask you calculate the value of KC in this equation, KC in this equation, I'm writing it here only. If they ask you calculate the value of KC here only, so it will be E naught cell equals to 0.059 divided by N log of KC, right? What is E naught? E naught was 1.1. Here E naught was 1.1. So put the value 1.1, 0.59 divided by N. What was the value of N here? N was 2, right? This was E naught. E naught was 1.1, right? So here you can write that KC will be, this is 2, this is log of KC, right? It will be 0.03, and this will be 1.1, this is log of KC. Log of KC equals to 1.1 divided by 0.03. Then you need to take the anti-log here, right? Then you need to take the anti-log here, 1.1 divided by 0.03, right? You can say this is 1.1, just give me a minute. 1.1, let us see, anti-log of this, 1.1 multiplied, divided or multiplied? It will be divided. Divided by 0.03, that will be 36.66, right? So that will turn out to be anti-log of 36.6, right? Okay, so here, as I told you in the first lecture, the anti-log of this thing you can calculate, right? This I told you, right? This I told you, but here, so I have taken a random value, right? What they will give you? They will give you antilog of those things which you can calculate actually. Basically, this is a positive antilog, right? Convert it into 10 raised to power, right? Then see that which is this equation. Most probably, they will give you only those values, right, which you can actually calculate. So that this is 36.6, no? So you can take it as 36, right? And this, you can take it as 36, 6 into, do the multiplication, right? And then you can calculate. You just need to apply the values, you just need to apply the properties of antilog here, right? This I have told you in the first lecture of log and antilog, right? First lecture of log and antilog. From there, you all need to apply the values and then you will get the value of antilog. So most probably, if you talk about KCET, in this, most probably they will give the answer as in the option you will see antilog of 36.6 only, right? If you talk about the level of JE, then you need to solve this value, right? If the value of antilog is very easy, then they will ask you, then they will think that you need to understand that what will be the answer for that. But here, as the value is little complicated, right? So here the value is 36.6. You need to apply the properties here, then convert it into a simpler value. That is why I'm saying in the option you will see antilog of 36.6 for a difficult antilog. But for easy antilogs, you will need to apply the properties. Easy antilogs, how to calculate, that I have told you in log and antilog. Right? Okay? Understood? Don't be scared of this thing. Right? The thing which is not asked in KCET that I am already telling you. Right? This thing they will not expect from you. Right? Okay guys? Everybody in the chat box. Everybody in the chat box. Now, there is one more formula. Right? There is one more formula. That is, wait a minute. Yes. Delta G equals to delta G naught plus RT ln of QC. Right? That is another formula. So here also at equilibrium, do the same thing. I'm going to give you the last equation here. Right? So here it will be delta G naught will be equals to 0. Right? Okay. Delta G is equals to 0. And QC will be equals to KC, right? And now, here what you will do, just put this value here. This will be equals to 0. This will be as it is. Then 0 is equals to delta G naught plus RT ln of QC. Then this will become delta G naught is equals to minus RT ln of QC, right? Then this will become minus of 2.303 RT log base 10 of QC, right? This will become your delta G naught. This is the formula that you are going to use for numericals, right? This is the formula that you are going to use for numericals. Is that clear to everybody or not? Is that clear to everybody or not? Delta G naught is equals to minus 2.303 RT of log base 10 QC. This is not QC, this is KC. Let me put it here. This is KC, right? KC, because at equilibrium, this will become KC, right? So that was the relation between E naught and KC. This is the relation between delta G naught and KC, right? Both of the things, if they ask you equilibrium constant, you need to calculate the antilog, right? But as I told you, antilog of easy things will be asked to you, not the difficult things, right? They can expect you, either they will write just thing. Here they can also write this thing that I have calculated here. Here in the option, you can also see log inverse of 36.6. This also can, because antilog is log inverse only, na? So this is also the option that you will see. Okay? Yes? Yes, everybody? Huh. Very good. Now there is one more formula. There is one more formula that one student is writing there. Right? Now E naught cell KC. E naught cell Kc and delta G and Kc. These values we have calculated. From this, there is one more equation, right? After solving the equation, you will get delta G naught, the relation between delta G naught and E naught. Okay? Okay, guys? Here it is between delta G naught and Kc. Here it is E naught and Kc. Now, after comparing these two equations, we get a new equation, right? And what is that equation? Minus NF E naught cell. Delta G naught is equals to minus NF E naught cell. Or you can say delta G is equals to minus NF E cell. Very, very, very important and highly asked question. Right? A very important and a highly asked numerical based formula, right? All these questions can be asked to you, right, everybody? All these questions can be asked to you, right? Okay? Okay, guys? Okay, everybody. Now, let us see the feasibility. Feasibility of reaction. Feasibility of reaction means if this thing can happen or not. If this thing is spontaneous or not. So spontaneity means delta G should be negative. If delta G is negative, if this is negative, negative, this has to be positive. That means E cell should be positive. Right? If this is now for a spontaneous equation, that is a feasible reaction, that means a spontaneous reaction, right? Delta G is negative. If delta G is negative, if delta G is negative, if this is negative, this will automatically be positive, right? So that means E cell should be positive. Now let us see what is the condition for Kc. If you see that E naught cell, or put anything, if I am saying that delta G is negative, if this is negative, then this thing will be positive. That means log Kc will be positive, right? Kc is positive only for when Kc is greater than 1. Log Kc is positive only when Kc is greater than 1, right? That is the first case from where we can know that Kc should be greater than 1. Or you can say yes. Now, here, if I say E naught cell, if I talk about the equation for E cell should be greater than 0. That means it should be positive. If I say this is positive here, if I say this as positive here, then this whole thing should be positive. That means log Kc here also should be positive. That again means Kc should be greater than 1. That means for a spontaneous reaction, the third condition is Kc should be greater than 1. So these are the 3 conditions for spontaneous reaction, right? Or a feasible reaction. Okay, guys? This is the spontaneous. No. Spontaneous means that occurs by itself, right? If I am saying that I am drinking water, right? Or I am, let's say water is falling in a waterfall, water is falling, right? So it is falling by gravity, by itself only, right? Or if I am eating something, digestive system is working on itself. I don't have to tell and call the digestive system so that it can work, right? Our digestive system is working by itself, right? So that is a spontaneous reaction that are happening. And most of the natural processes are spontaneous only, right? Like blinking of eyes. That is not, we don't tell our mind to blink, right? Blinking of iris, it is very natural process, right? It will occur by itself, right? Okay? Yes? Okay. Now, last topic of today that is also related. If they ask you that you have one equation, one reaction I am writing here. Wait a minute. One reaction I'll be writing here. Just give me a minute. Right, one reaction I am writing here. You have Cu2 positive, 2Cu. You have Cu positive is positive. This is Cu positive, 2Cu. Right, here it is gaining 1 electron. Here also it is gaining 1 electron. Here it is giving out to be 0.15. Here E1 E naught 1 is giving out to be, it is 0.15 and it is 0.5, right? Okay guys, now this is E1, this is E2. They're asking you for Cu2 positive to Cu. What is the E naught of, this is not, okay, E naught of Cu2 positive to Cu. Now remember one thing, firstly make the chart of this thing, right? Firstly make the chart of this thing. What is this chart, right? The chart is from Cu2 positive to Cu positive, right? Then Cu positive to Cu, right? And they are asking you directly from Cu2 positive to Cu, right? If I take it as 1, 2 and 3, E1 is given to me, E2 is given to me, E3 they are asking, right? Okay. Here the number of electrons that are gained is 1. Here N1 is 1, N2 is 1, because here also the number of electrons gained is 1. Here also, here the number of electrons from Cu2 positive to Cu, number of electrons, that is N3 is equals to 2. 2 electrons it is gaining. So N3 will become equals to 2, right? They are asking you the value of E naught. Remember one thing, E naught is non-additive, but Gibbs energy is additive, right? That means I can't say that E naught of 1 plus E naught of 2 is equals to E naught of 3. That's not additive in nature. I can't say this plus say that this is the path, you add these two paths and this will be equals to this path. That is the wrong thing, because electrode potential is not additive in nature. But delta G naught of 1 plus delta G naught of 2 is equals to delta G naught of 3, right? So this is the same equation we will apply here, right? And what we will get, we will get this thing. What we will get? We will get this thing. Delta G naught of 1 plus delta G naught of 2 equals to delta G naught of 3, that is equals to, what is delta G? What is delta G and E naught? What is the value? It is minus NF E naught cell, right? So just need to apply here. Minus NF E naught of 1 minus N is 1 here, right? Here N2 is also, here it is N2, F E naught of 2, and here it is N3, minus N3, F E naught of 3. I just applied the formula here. Delta G is equals to minus NF E naught. F is Faraday, it will cancel out, right? And minus will also cancel out. So it will be N1 E1 naught plus N2 E2. You don't need to cram any formula. This is the way to solve, okay? So this is N3 E naught 3. So E3 will become equals to N1 E1 plus N2 E2 divided by N3. Now E3, that means, what is the third? Third is from Cu2 positive to Cu, right? So this is Cu2 positive to Cu. It will become equals to, what is N1? That is 1. What is E naught 1? That is 0.15. 0.15, right? 0.15 plus 1, and this is 0.5 divided by 2. And this is after the solving, you will get your answer, okay? After solving, you can get your answer. Is that clear to everybody or not? Everybody, is that clear or not? So this is how you will get answer for calculating this is basically called conservation of energy, and this is how you can calculate the value of E3, right? Okay, they can even ask you, they can give you the value of E1, they can give you the value of E3, they can ask you the value of E2, right? So many things can be, ma'am, in what kind of questions? Other chart can be like this, other chart can be like this. It can be like this. For example, they are saying that Fe positive to Fe2 positive, right? then to Fe2 positive to Fe3 positive, and then you have directly from Fe positive to Fe3 positive, right? So the same thing, right? This is the same thing. Okay, guys, so these kind of things they can ask you, right? Remember, electrode potential is not additive in nature, but Gibbs free energy is additive in nature. Okay, everybody. So, guys, that was all about Nernst equation and the equations related to that, right? Now, in the next class, we are going to do electrochemistry only, right? Some of the questions, we will do practice questions, and we will do also Faraday first law, second law. We will do what is molar conductance, conductivity, all of these things we will do. And from that, the questions that are asked to you is from conductivity, from Faraday's law, from Coriolis law. Very, very important topics. Okay, guys. Okay. Very good, PU. Basavana, very good, Basavana. I'm so happy that you're able to understand everything, right? And that is why we are here, so that you can understand everything in a very simple way, in a very simplified manner. We can give you the detailed information, right? But for that, I want all of you to also share this lecture among your friends, so that we can reach out to a larger audience and we can help them out, right? So that is one, I would say, advice and one request to you. Reason being, that is not only going to benefit me, right? That is going to benefit you as well, right? So more students, more content, and more, more appreciation, and I would say more happy mood I will be in, right? And definitely for the students who are sitting out there in some, like in their house, they're just thinking that I want to crack KCET, but I don't have any guidance here, right? So we can help them out, right? So help them, right? Share this among your friends, among your juniors, among your senior, if there is any dropout student, right? Among in your other school friends as well, right? So that is one thing. Okay, guys? Yes. Yes, definitely classes will be provided to you regularly. Okay, then bye-bye. Take care. See you all in the next class for electrochemistry. And I want all of you to write down your feedback in the comment section. Every single comment matters to me. Right now, I was just busy with something, some of the personal commitments I was busy with. That is why I was not able to see your comments. But now I am absolutely free. And now I'll be replying all of your comments, right? And I'll be waiting for your comments, like regarding what you need next and what is your thought on my teaching and what else you want on this channel. Okay, bye-bye. Take care. Good night. Keep smiling and keep spreading the love around you. Bye-bye.